following the opening curly brace, and then the 2 lines following the if-def are passed through to the translation unit. Notice that in our program source code, over on slide 9 here, we used the token pi to specify the initial value of the double variable, lowercase pi, and in the translation unit, that token pi has been replaced by the sequence of characters specified in the pound define for pi, that is 3.1415, etc. Now, following that statement, double pi gets 3.14 blah blah, we have an else in the source code. Now the else, up to including the end if, all 4 of those lines are not passed along to the translation unit because pi was a pound define, and consequently only the lines of code between if-def pi and else were passed along to the translation unit. So following double lowercase pi gets capital Pi, we have 4 blank lines in the translation unit over here on slide 11. The next 3 lines that we have in the source code don't make use of any pound-defined tokens and don't involve any conditional compilations or includes. So those final 3 lines are simply passed through into the translation unit, and with that, our translation unit is finished. I should mention here that the translation unit on slide 11 may look like it has more space in it than the source code shown on slide 9, but actually that's just due to PowerPoint formatting issues. On slide 9, in order to make the entire source code file fit on one slide, I had to tighten the line spacing quite a bit, whereas on slides 10 and 11 that show the full translation unit, I went ahead and used PowerPoint's default line spacing. Alright, so to review, on slide 9 we have the source code file foo.cpp that the preprocessor reads and converts into a translation unit, which is then passed on to the compiler phase of the compilation process. The first part of the resulting translation unit was shown here on slide 10. Here we have notations, pound, space, and then a line number, followed by some other notation. Often that other notation is a file name indicating which file we're currently processing. Sometimes that notation is something like built-in or command line. These notations, pound, space, line number, are to tell the compiler which line number we are currently in the file, so that if an error is encountered during the compiler phase, the compiler can report which file and which line in that file the error occurred on. Okay, so the first line contained a comment, resulting in a blank line in the translation unit. The second line contains a pound include directive, so that switches us from foo.cpp into line 1 in foo.h, and as we saw in foo.h, there were 3 lines. There was a comment resulting in a blank line. Then there was a pound define of pi, resulting in pi being defined internally, but a blank line in the translation unit. And the third line was this declaration of the function ABC. Then we switched back to foo.cpp on line 3 in foo.cpp, and went through the rest of this code. So we've got a line int main, then we've got a line for the opening curly brace. The if-def pi is replaced by a blank line. The 2 subsequent lines between if-def pi and else are passed through to the translation unit. Then we have 4 blank lines in the translation unit corresponding to the else and the end if, and the 2 lines between the else and the end if, and then the trailing 3 lines. Now, other compilers, as I say, will produce their own kind of notation in the translation units to provide information to the compiler phase about which file and which line is currently being processed. But this is the general idea of what gets passed to the compiler after pre-processing is done. We need to care about conditional compilation, pound-defined tokens, and so forth, because it will affect how we develop our header files for our classes. Now, for a class, the header typically contains the definition of the class. That is, the name of the class, stock in this case on slide 12, then a list of declarations of public members, typically member functions, and a list of private members, typically data members. And there may be other things in this header file as well, such as explicitly defined inline functions, templates, symbolic constants declared with const, and the like. Now, in an application, you're only allowed to define a class that you want to use one time. Here on slide 13, we have an application, that is, we have a main function that wants to be able to declare and use stock objects. We have stock S1 here in main. So we're going to need to include the stock header file one time to pull in that definition, but it will be an error if we accidentally include that stock header file a second time, because the way that we've written the stock header file, that will end up defining the stock class twice. And even though those declarations are identical, that's still an error as far as the compiler is concerned. So you can say, well, just don't do this. Just don't include stock.h two times. That seems reasonable, but consider this situation. Suppose that you have developed options on stocks, and you have an option class. Here we have an option object named O1 being used in the main function. It should be clear that the option class is going to have to know about the stock class in order for the option class to be able to describe and compute option prices on stocks. Now, as the application programmer, we know that we're using stock objects in our application, so that means to us that we have to include our stock header, but we're also using option objects in our application, so we have to use the option header as well. And as shown here on slide 15, this is going to cause a problem, because the option header, since the option class needs to know what a stock is, the option header will typically also include the stock header. And consequently, in our application, when we include option.h, that is going to end up including stock.h a second time, even though we, developing our application code, don't see that that's happening. So here we have a situation where we're developing an application using stocks, so we include stock.h. That application is also using options, so we include option.h. But options have to know about stocks, and so the option header will also include stock.h. So we have a situation where we've accidentally included stock.h two times, and that's going to give us an error.